So in this video, we're going to be working with a little bit harder trig equations. In this case, we either going to factor or we do have to use the identities. Right? So again, my first step here is to combine like terms. In this case, I'm moving everything to the left side of the equation because as we review on the quadratic equation video, we saw that whenever we have the term and the term square, we're moving everything to the same side of the equation. On this case, we can either go and substitute. So let's say that x equals to sine of theta, and then if I square on both sides, that x squared equals to sine square of theta. So that means that I get 2x squared plus x minus 1 equals to 0. We can use the box method that I showed in that video. I get the 2x squared, the negative 1, then 2 times negative 1 is negative 2x. So two numbers here multiply and give you negative 2, and add to positive 1, it has to be 2x and negative x. So 2x here, negative x. And factor out on the first line, so I get 2x. On the second line, I'm factoring negative 1. On the first column, I'm factoring out an x. And on the second column, I'm factoring out a 1. So that means that my factorization here is 2x minus 1 times x plus 1 equals to 0. Again, my product, 2 times x is 2x squared. Negative 1 times positive 1 is negative 1. And then 2 times 1 is 2. Negative 1 times x is negative x. So 2x minus 1 is x. So from here, I get 2x minus 1 equals 0. So 2x equals to 1 divided by 2. I got that x equals to 1/2. And then from the other one, x plus 1 equals 0. So x equals to negative 1. Now, of course, I'm not finding x, I'm finding theta. So I'm going to put back sine of theta here for x. So that means that I got sine of theta equals to 1/2, or sine of theta equals to negative 1. So that means that here theta equals to 270. And in this case, let's do the triangle here quickly, right? The 30-60-degree triangle. So 30 here, 60. I get 1, square root of 3 and 2 is sine, so it's opposite over hypotenuse. So that means that my reference angle is 30. Because it's positive, it's going to be on the first quadrant. And on the second quadrant, so 180 minus 30 degrees is 150. So my solutions are 30 degrees, 150 degrees, and 270 degrees. Go to the next one. Again, in this case, I'm going to rearrange this as tangent square of theta plus 2 tangent of theta plus 1. Actually want to write the equal sign, right? Equals to 0. Again, I'm factoring here. If you need to substitute as I did on the previous one, you can always do that. So tangent of theta plus 1 times tangent of theta plus 1. So this is the same as tangent of theta plus 1 squared. This will be 0 whenever this is 0, so I can just take 1. Tangent of theta plus 1 equals to 0, so that means that tangent of theta equals to negative 1. Using triangles, again, we know that this is 45. I have 1, square root of 2. So tangent will be 1 whatever is 45 degrees, my reference angle, but it has to be negative, so that means that it's going to be on the second quadrant. So 180 minus 45 is 135 degrees, and it's on the fourth quadrant, so 360 minus 45 is 350. Remember that it's in the second and fourth quadrant because when I divide sine over cosine, it has to be negative. And because it has to be negative, that means that either sine is negative and cosine is positive, or cosine is negative and sine is positive. Let's see the next one here now. The next one, again, I'm going to start by combining like terms. So I'm going to start by subtracting the 5 here. So I get 1, negative 1 equals to cosine of theta minus sine of theta. Now, so remember, there's no identities. No identities that can combine cosine and sine without the square, right? The only one that we can work through is this one. Cosine squared plus sine square of theta equals to 1. So that means that my first step after I combine like terms, again, your first step should always to combine like terms, so you simplify your equation, is to square on both sides. So I got positive 1. Don't forget that here I'm actually foiling it. So I'm multiplying cosine times cosine, and so on, right? So I got sine of theta minus sine of theta times cosine of theta minus sine of theta. So I got cosine square of theta, right? Then negative cosine times negative sine, so negative cosine of theta minus sine of theta. Again, minus, oops, not minus here. Let's fix that one. Just cosine of theta times sine of theta minus, again, cosine of theta, sine of theta, and then plus sine square of theta. Again, cosine times cosine, cosine times sine, sine times cosine, sine times sine. Now, keep in mind that this right here, that this plus that is the same as this identity that we have here. So that means that I can substitute the 1, then I have minus 2 cosine theta sine of theta. Then I can subtract 1 on both sides, so I got 0 equals to negative 2 cosine of theta sine of theta. And if you want, we can divide by that negative on both sides, so I got 0 equals to cosine of theta sine of theta. Now that I have a product of two factors here, I can take that cosine of theta equals to 0, or that sine of theta equals to 0. So theta here, where cosine is 0, is at 90 degrees and 270 degrees. And then theta here is at 0 and 180. Now, keep in mind that those are the solutions of this equation that we created here. Right, that equation that we created when we square, but not necessarily are the ones here. So anytime that you square, we're going to have to go and check for Spanish solution. So I got 4 equals to cosine of 90 minus sine of 90 plus 5. So I'm substituting each one, the 90, the 270, the 0, and the 180 on the original equation. So that means that I got 4 equals to 0 minus 1 plus 5. So I got 4 equals to 4. Then I'm going to do the same with the 270. So 4 equals to cosine of 270 minus sine of 270 plus 5. So I got 4 equals to 0 minus negative 1 plus 5. So I got 4 equals to 6. So this is not true. So that means that 270 is not a solution. I'm going to do the same with the 0. So I got 4 equals to cosine of 0 minus sine of 0 plus 5. So I got 4 equals to 1 minus 0 plus 5. 4 equals to 6. Again, this is not a solution. And at the end, I'm going to do the same with 4 equals to cosine of 180 minus sine of 180. 180 plus 5. So I got 4 equals to negative 1 minus 0 plus 5. So 4 equals to 4. So that means that my solutions here are 90 and 180 degrees. So exercise 4, you see that we're not adding or subtracting. We can always square, but it's going to be a little bit easier if we go like this. Let's start by dividing cosine of theta. So cosine of theta, remember that sine over cosine is the same as tangent. So that means that I got the square root of 3 tangent of theta equals to 3. Next step here, I can take out the square root on both sides here, so I can isolate tangent. So I got tangent of theta equals to 3 square root of 3. If I rationalize here, I got the tangent of theta equals to 3 square root of 3 over 3. So that means that tangent of theta equals to just the square root of 3. So that means, again, if we use a triangle, right, that includes the square root of 3. If we use a triangle that includes the square root of 3, I got 30 here, 1 square root of 3, that is 60, right? And 2, so that means that tangent square root of 3, that means that tangent of 60 is the square root of 3 because it's opposite over adjacent. So that means that I get that theta equals to 60. And then now, because it's positive tangent, that means that next one is going to be on the third quadrant. So 180 plus 60 is 240 degrees. And this one we can always square. like we did on number 5. But if we have something like that where we're not adding or subtracting anything, we can just simplify it. Let's see the next one. Let's see 5. So 5 now, look that I have 2 theta here, and I have theta, right? So I cannot combine them. I cannot divide by that 2 or anything because that 2 is inside of the sign, right? So if we use order of operation, I'm supposed to use the sign first. So I cannot just divide by 2 and cancel it out. But look that I have 2 terms with sine of 2 theta. So what I can do here is I'm going to subtract this 2 sine of 2 theta on both sides, minus 2 sine of 2 theta. So that means that I got sine of theta equals 2 sine of 2 theta. Right? My next step is that I can move the sine of theta to the other side. So I get 2 sine of 2 theta minus sine of theta equals to 0. As a review, sine of 2 theta, the only way that I can remove the 2 theta, is by using my identities. So in this case, sine of 2 theta is the same as 2 times sine of theta cosine of theta. So that means that I can substitute here 2 sine of theta cosine of theta minus sine of theta equals to 0. Now, as you can see, I have a common factor here. That is sine of theta. So I can factor out the sine of theta. Right? And then I have 2 cosine of theta minus 1 equals to 0. Remember again that whenever I factor like that, if I distribute here, if I multiply again, I should get the same thing. So if I multiply sine of theta times 2 cosine of theta, that's the same as 2 cosine of theta cosine of theta, and sine of theta times -1 is sine of theta. So now that I have 2 factors, I can equal to 0. Cosine of theta minus 1 equals to 0. So from here, theta is 0 at 0 degree and 180 degrees. And from here, we get equals to 1 divided by 2. So cosine of theta equals to 1/2. And then cosine of theta equals to 1/2. Again, let's draw the triangle really quickly here so you can see it. So I got the 30 here, the 1, the square root of 3, and the 2. So 1/2, cosine of 1/2, then it has to be cosine of 60, right? Because it's adjacent over hypotenuse. So again, that means that theta is 60 degrees. And again, because it's positive cosine, that means that it has to be on the 4th quadrant. So that's going to be 300 degrees. So my solutions here are 0, 60 degrees, 180, and 300 degrees. The next one. Can I have a 2 theta here? Look that I don't have I have a theta and 2 theta. If both of them had 2 theta, then I can just move the 1 and factor out. But because I have one with 2 theta, one with 2 theta, one with theta, I gotta convert. And again, I gotta use the identities. On this case, right? We have 3 different identities for cosine of 2 theta. On this case, I'm using this one. So I can keep the same one, right? I have already got cosine over here, so I'm gonna use the one that just have cosine. So that means that I got 1 equals to 2 cosine of 2 theta. Then this cosine of theta becomes this, so plus 2 cosine of square root of theta minus 1. Right? I'm going to add the 1 on both sides, so I got 2 equals to 4 cosine of square root of theta, and I can divide by 4. So I have 1/2 equals to cosine of square root of theta. Then I can take out the square root here. So that means that, don't forget that now we have cosine of theta equals to plus or minus the square root of 1 is 1 over the square root of 2. So this is the same, if I rationalize here, as cosine of theta plus or minus square root of 2 over 2. So that's happening at, at 45 degrees. Then because it's the plus or minus, I got to find an angle on every quadrant. So 135, so 180 minus 45, 180 plus 45, and 360 minus 45. And that's it for this lesson. May the fourth be with you.